Woohoo! Good morning, Professor David J. Okay, it's October 1, 2023. The time is 3:30 a.m. Okay, my topic for this session will be college algebra. Okay, don't worry guys, we will finish college algebra. And we are now on lesson number 78, and this is the title of the topic is a rectangular coordinate system, or the so-called Cartesian coordinate system. I was a little bit hesitant to include this one under college algebra because Cartesian coordinate system is actually a topic under analytic geometry. And when I took up my engineering, we didn't include Cartesian coordinate system on the college algebra. It's another topic, and this is a concentrated topic on the so-called analytic geometry. So, but we are here in the USA, so we must have to include it because this falls under the topic linear equations. Okay, and they are related to the so-called Cartesian coordinate system. Okay, let's proceed. The subject matter for this morning will be college algebra. This is lesson number 78. We are running smooth. We are almost done with college algebra. These are just additional topics I included in the college algebra topic that I am lecturing. The title of the topic will be rectangular coordinate system, or the other term for this is the so-called Cartesian coordinate system. Okay, this is being used by the military to, what you call this, locate the enemy on the coordinates. So there is the so-called coordinates, right? So if they could pinpoint your location on if they could get your exact coordinates, they could fire something on you to hit you, right? So that's an application of this system here. Okay, so much with that. Okay, let's proceed with the properties of the so-called Cartesian coordinate system. For the Cartesian coordinate system, there are terms which are needed to be, what you call this, defined, and I write the terms that are needed over here just to understand what is Cartesian coordinate system. Number one, x-axis. X-axis is this one, the horizontal line. That's why I mark this as x. So this is x-axis. Okay. Y-axis. Y-axis is actually this line here. And I mark this one by capital letter Y, meaning it is y-axis. The other term for the x-axis is actually the so-called horizontal line. X-axis is, the other term is horizontal line. Y-axis, the other term is actually vertical line. Okay, there's no hard thing about it, right? What is the term origin? Origin, if we try to bring out the definition, origin is the intersection of the axis. Axis here is plural because axis with an I is just singular, right? So if we try to take the plural of axis, meaning two axes, that's plural. So this axis here refers to the x and y axis, meaning the intersection of the x axis and the y axis is referred to as the origin. It is this. If this is the x axis and this is the y-axis, their point of intersection is termed to as origin. Okay, under Cartesian coordinate system. So at least we now know what is an x-axis, what is y-axis, and what is origin. Next one, quadrants. Oh, this is where the military use this one. They might say that you are in quadrant number 3 and they are on quadrant number 1, so they could target you here on quadrant number 3. Okay, they will just get their compass here. So actually they could measure your distance from their location, and if they try to program their M1, A1 Abrams, okay, they could hit you immediately. So that's the significance of these quadrants here. If we try to define what is quadrant, it is the regions bounded by the axis. Axis meaning the x-axis and y-axis, this is plural, right? So the regions bounded by the x-axis and y-axis are termed to as quadrant. So if you are on this first part here, okay, where's my green pen? First one. If we are on this location here, you are on quadrant number 1. Okay? If you are on this location, bounded by this vertical line and horizontal line, you are on quadrant number 2. If you are on this location here, bounded by this horizontal line and vertical line, what they call this horizontal line to the left and a vertical line down, you are on quadrant number 3. If you are on this portion here, bounded by this horizontal line and this negative vertical line, you are on quadrant number 4. Okay? The significance of this, it's just like if this is the location of some group of soldiers, and this is the location of another group of soldiers, and they are trying to kill each other, right? So if they want to fire something over here, if they could pinpoint your coordinates, they could hit you. So that's the importance of this rectangular coordination. That's why if you see it, military people, they've got a map, okay, and they got their compass, right? And they are measuring distances on the compass on the map, because the map is actually drawn to scale. Whatever the reading on the compass, okay, multiplied by the scale, they will know how many miles, how far away from you from them, right? You know, that's the significance of this rectangular coordinate system. Okay, what's next? Ordered pair. To designate a point on the Cartesian coordinate system, we must have to bring out the so-called coordinates. There should be a coordinates. It's either the x coordinate or y coordinate. So if you try to bring out the exact location of this, you must have to bring out the coordinates, meaning its abscissa and ordinate. Its abscissa and ordinate, like if this is point 2, its abscissa is x sub 2 and the ordinate is y sub 2. For point number 1, the abscissa will be x sub 1, okay, and the ordinate will be y sub 1. That's the meaning of this. Okay, to pinpoint the exact location of any point on the Cartesian coordinate system, you must have to bring out the value of x and the value of y for that point. Okay? What is x? What is x here? Okay, I will try to bring out the meaning of this x and y here. For x, the other term is actually x coordinate, or the other equivalent of this, we term this one as abscissa. Abscissa. This is EBS, CIS, double S, and A, abscissa. And for y, we term this one as y coordinate, or simply ordinate. Okay? That y portion is termed to as ordinate, and that x term is actually as abscissa, or the long-term equivalent is x coordinate or y coordinate. But if you are studying analytic geometry, if we see x, we see immediately abscissa, and if we see y, we just see coordinate. It is understood that they are the y coordinate and x coordinate. Okay? Oh, so these are the needed terms in order to understand what is a Cartesian coordinate system. Okay? There's a horizontal line or termed to as x-axis. There's a vertical line which is termed to as the, what they call this, y-axis. The intersection of the vertical line and the horizontal line is termed to as the origin. This portion, area of the region here is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And this is quadrant number 4. And to designate a point on the Cartesian coordinate system, we must have to specify its abscissa and its ordinate. Okay? The plotting of the abscissa and ordinate is easy. Any abscissa to the right will be plus. For x. For x, it should either go to the right or either go to the left, right? If we are plotting along the x-axis, you either go to the right or go to the left, right? And if you are plotting ordinate, either you should go up or you should go down. Go up will be plus, okay? Go down will be minus, that is for the ordinate. For the abscissa, if you plot it to the right, it should be plus. And if you plot it to the left, it should be minus. As simple as that one. Okay? So at least we now know how to plot a point on the Cartesian coordinate system. Okay? Okay, let's try to bring out the first formula under the study of Cartesian coordinate system. This is actually analytic geometry. It's not a part of algebra. Because the one who made the syllabus for college algebra, they mix up the algebra portion with the analytic geometry portion, you know. But since they included it, okay, we include it, right? Let's try to bring out the first formula on how to compute the distance between 2 points on the Cartesian coordinate system. This one is being used by the military. But in the military side, if they got the map, okay, they will just use the compass like this. Then they will try to convert that length of the compass, the one measured by the compass. They will know immediately how many miles will be the distance from point number 1 to point number 2. Okay, because the map is actually drawn to scale. That's why our spy planes are actually what they call this, taking photos. So when they make the map, they will draw it to scale. So the military men on the ground, if they try to measure the distances between 2 points, okay, on the Cartesian coordination, they will just use the compass like this. Then they will convert that distance to a certain percentage because the map is actually drawn to scale. So if you measure 4 inches here, they will multiply by that one by a certain factor and they will know immediately the distance between point number 1 and number 2. Okay? Okay, let's try to bring out the first formula under Cartesian coordinate system. I will try to erase this one so it will look good. Even this one. This one. Okay. Okay, let's try to get the distance between, actually this is point number 2. Point number 1. This should be point number 1 with the subscript 1. The coordinates will be x1 and the ordinate will be y1. This point here will be x1, y1. This point will be x2, y2. We are asked to find the distance between them. Oh, it's just the Pythagoras principle, you know. if we try to draw a right triangle here, okay, then we'll bring out this right triangle. That right triangle will be this one. Okay. If we try to get this distance here, it should be x of 2 minus x of 1. And if we try to get this distance, okay, it should be the difference y of 2 minus y of 1. How is that so? It is just like this. It's easy to visualize, right? This one, this is y sub 1. This is y sub 2. Okay? This height here is y sub 2, right? And this height here is actually y sub 1. So if we try to compute for this distance here, it should be the difference y sub 2 minus y sub 1. It is this. Right? On the abscissa, it's the same. I will try to erase this one. I will project this one, then I will project this one down. This one here is x1. The abscissa of this point. And the abscissa of this point, I will place that one as x of 2. The horizontal distance of this point here with respect to the vertical is actually x of 2. So if we try to compute for this distance here, it should be the difference x of 2 minus x of 1. So this side here is x of 2 minus x of 1. And this is a right angle. So we will be using Pythagorean theorem, the one we know, right? We are computing for the hypotenuse. So if we use Pythagoras principle, the square of the hypotenuse, and which we represent it as the distance between points number 2 and number 1. So the quantity square is equal to, this side here is x of 2 minus x of 1 quantity square. And this side here is y sub 2 minus y sub 1 quantity square. Then to solve for D, we raise both sides to the 1/2. Right? Then we apply our knowledge on the laws of exponent. D square raised to 1/2, these two here cancel with D. Left hand side, it is simply D now. And for the right hand side, the sum of these should be raised to 1/2, so this is under 1 square root. So the distance between points number 2 and 1 now will be the square root of the quantity x of 2 minus x of 1 quantity square plus y sub 2 minus y sub 1 quantity square. And that is actually formula number 1 under analytic geometry. It is this. Okay? We call this one the so-called distance formula. Okay? So under the Cartesian coordinate system, to determine the distance between any 2 points, just use this formula. Actually, this one you could interchange it. You can make it as simply x of 1 minus x of 2 quantity square plus y sub 1 minus y sub 2 quantity square. Okay? If the difference inside will be negative, don't worry, because this is of the second power. It will still be a positive distance. But just to be safe, I'll just use x of 2 minus x of 1. Okay? For the difference of the two numbers inside will be positive. So for analytic geometry or under Cartesian coordinate system or rectangular coordinate system, the number 1 formula that must be memorized is distance between 2 points will be the square root of x of 2 minus x of 1 quantity square plus y sub 2 minus y sub 1 quantity square. Okay, that's it, guys. This is just an introduction of the so-called rectangular coordinate system. The next time around, we'll try to solve problems involving distance formula. Then we'll go with the next lesson, that is there are so many topics over here. And this is in preparation for your higher mathematics. Okay, good morning from Los Angeles. This is Professor David J.